Hello everyone, welcome to pipebench.com. HTTP pipe has been used in many marine applications. Because the density of the HTTP pipe is less than water, so it will flow even when the pipe is filled with water. Therefore, we will have to install some weights, like concrete weights, on the pipeline to make sure it can be lowered under the water. Recently, we have developed a great tool using the equations included in the Handbook of PE Pipe, published by Plastic Pipe Institute, to help you to determine what's going to be the weight for each ballast and also what's going to be the spacing. Okay, let's take a look. For the pipe input data, it's pretty much the same as all our PE pipeline calculation tools. You can select the dimension standards. In this case, I still keep using IPS, which is more common. For the pipe size, we can go for, let's say, 16-inch, and let's assume it's going to be DR11 PE pipe. And the next one is a fraction of inner pipe volume occupied by air. So instead of using percentage, here is a little bit tricky. So it's ranging from 0 to 1. So let's say we're gonna design the pipeline assuming there are gonna be 20% air exists in the pipe, or 10%, or even you want to go a little bit more conservative. You can even assume it's gonna be full air. So let's say we want to design this spacing, assume there's a 20% air in the pipe. So in this case, we can just put 0.2. And scroll down, this can be density of water outside the PE pipe. So if it's in the ocean, we suggest you put in something like 64 pounds per cubic feet as ocean water density. And if it's a fresh water, we can put a 62.3. So in this case, let's use 64, assume it's going to be installed in the ocean. And the density of the fluid content, which is the content inside the pipe. So in this case, we will say is the water in the pipe is going to be the same ocean water around the pipe. So we can change it to 64. And coming down this side, we can put on some weight of ballast in air. So this can be changed. A lot of times we have to try a different way to make sure it's going to work. So like in this case, let's say we put in something like a 250 pound each of weight. Please note, this is the weight of ballast in air. So it's different from the weight of ballast in water because it considers the buoyancy of the weight in the water. So the actual weight downward force caused by the weight in the water is actually less. So anyhow, the next input is density of ballast. So density of ballast is typically we put a 150 pound per cubic feet because concrete ballast is pretty commonly used in this type of application. And the typical for reinforced concrete density is 150. Of course, you can change it by tick the box at the beginning, and if you use other type of ballast, you can put the density. But here we recommend using the typical value if you use a reinforced concrete ballast. Okay, so here by putting everything here, we should get the maximum Ballack spacing is 10 foot. 10.4 foot. So this is actually the spacing ballast we actually gonna select. We have some typical range recommended by the PE handbook. So for 16-inch, usually is ranging from 10 to 20 foot. And in this case, let's say we're gonna try 20 foot. Because it's more than 10.4, so it doesn't work. So let's say if 10 foot apart, apparently it's gonna work. So what if we're gonna assume more air could possibly in the pipe? Let's say the pipe could eventually gonna be sink under the water, but due to the operation, sometimes you will have more air, a slack of air going into your pipeline. So in this case, let's say the worst scenario, everything is the pipe is full of air, you will see the maximum upward force caused by the buoyancy force. So in this case, we just simply change the fraction of inner pipe volume occupied by air to 1.0. This means 1% volume occupied by air. So in this case, we can see that if we use 250 pound weight of ballast, the maximum spacing is only 2.38 feet. And we know this is a very extreme. We don't want that many ballast installed on the pipeline. It's very hard to manage. So if we want to keep 10-foot spacing, we need to keep changing the weight of ballast in air to make sure that it will work. So let's say we change it to 500 pounds. We'll see how that goes. Still, the maximum spacing increased to 4.75, but still doesn't work. So we still want to keep 10 foot. Let's say we keep going up. Let's say try 750, right? So 7.13 still doesn't work. So it looks like if we want to design to 100% occupied by air, we need something even bigger. So how about 1,000? 1,000. Okay, so 1,000 pound is going to 9.5. Really, really close now. And then we can either accept just install 9 foot apart and call it good, or if we want to keep 10 or more spacing, we have to keep going up. So in this case, let's say 1,200 pound, then we will get it work. So instead of 10 foot apart, the pipe will stay under the water, even there's a slug of air going into the pipe. Okay, great. So we finished the design, and we can just click the report button here, and you can put in some project info, dates, revision, and who did it, who reviewed it, who approved it. And in this case, we don't want to put all the generic information. Then you can generate a very nice PDF report, like all our tools on our website. And this will contain all the input data you put it in, and the results and recommendation. Just one more thing, if you work outside of the US, you want to use metric units, all you need to do is go into the top, and you see there's 2 buttons here, one for imperial, one for metric. All you need to do is just click metric. Then everything should be in metric units, and in this way we put it, or have all the inputs and outputs in metric. If you click on it, it will do the conversion by itself. So in this case, if you put in the report, it's going to be the metric units as well. Okay, great. That's everything about this tool. If you have any questions or suggestions, please feel free to visit our website, www.pipeengine.com, and leave us a message. Looking forward to hearing from you. Thank you.